Let's solve a polynomial inequality together. A quadratic inequality to be exact. Let's get started. Solve the given polynomial inequality. Report the solution in both interval notation and graphical form. Okay, so here is our polynomial inequality. Negative 6x squared less than or equal to 24 plus 30x. So we want to move all of the terms over to the left side, and we want to list it in descending order. So we're going to move this out a bit. Negative 6x squared. This was on the left side. It remains on the left side, so no sign changes there on that term. Then we want our x term. We're going to subtract 30x from both sides. That gives us minus 30x. And finally, we're going to subtract 24 from both sides, and that gives us minus 24. No terms left here on the right, so less than or equal to 0. Now, I want to factor out a negative 6 from all three terms. So factoring out is akin to dividing out. So we're going to take this negative 6, do the reverse of the distributive property, and factor out that negative 6 from each of those terms. And we're going to record what's left over. Negative divided by negative is a positive. 6 divided by 6 is 1. 1x squared, or simply x squared. Negative divided by negative is a positive term. 30x divided by 6, 5x. Negative divided by negative is a positive. 24 divided by 6 is 4, plus 4. Okay? And now we need to factor this trinomial. X times x, 1 times 4, and 2 times 2 could be an option. We're looking for factors of 4 that, because of this last symbol, add to 5x. Okay, so we make our choices. This is our only choice out front. 1 and 4, those are the factors that will add to 5. So we are going to get our factors ready. We're going to bring down this negative 6. It was factored out, it wasn't thrown out, so it's still a part of how to get back to our original statement. We place the x's, first times first. We place the 1 and the 4, last times last. Our sign rules. The signs will be the same, and this is how they will look when they are the same, plus and plus in our binomial factors. Okay, so all factored. Now, let's set each factor equal to 0 and solve for x. So, negative 6 does not equal 0, doesn't give me any information about x. Or it's possible that x plus 1 equals 0, or that x plus 4 equals 0. Solve for x, subtract 1 from both sides, x equals negative 1, or subtract 4 from both sides, x equals negative 4. So these two are my critical values, my endpoints. So I'm going to come up here, and I'm going to plot them on the number line. Negative 4 is smallest, and then negative 1. Now, my endpoints. Because of this equal to option, my endpoints will be closed. So I'm going to close them with dots for now until I test my intervals to see which way I'm going to shade. Also, less than 0 means I'm looking for negative intervals. I want solutions that's going to cause less than 0. So now, we have to test the regions between -4 and -1, and beyond -4 and -1. So to the right of -1, I'll find a 0 and test it. Between the two endpoints, I'm going to choose -2. And to the left of -4, I'm going to choose -5. Okay, so let's get started. I am going to use this factored form here to test everything. So that means -6 is always going to be a part of the problem. And I'm going to have to test -5 into the other two factors. So if I test -5 here, -5 plus 1 is -4. That's a negative. Test -5 here. -5 plus 4 is -1. So let's go back. I feel like I said the same thing. -5 plus 1. 1 take away 5 is -4. It's still negative. -5 plus 4. 4 take away 5 is -1. Still negative. I have 3 negatives. So I'm going to get a negative result here. Negative times a negative is a positive. Positive times negative is a negative. So this region is negative. And that's a region that I am looking for. I can go ahead and shade that region now. I'm looking for less than or equal to 0. I'm expecting these regions to alternate. Okay, I'm expecting negative, positive, negative, and I think I'm going to be shading, but I need to test. Sometimes anomalies happen, so let's go ahead and test the middle region. Starting with -6 and plugging in -2 for the other two factors. -2 plus 1, negative. -2 plus 4, positive. So now I have a positive times a positive. I'm going to get a positive region here as I suspected. Not looking for positives, so I won't be shading that region. Finally, let's test the last region by plugging in 0, starting with -6. 0 plus 1 is 1. That's positive. 0 plus 4 is 4. That's positive. So I'm going to get a negative result as I expected. And so I am going to shade that region. So let's go ahead and graph this. We have -4 and -1 as our endpoints. Now we know which direction we can place our brackets. Because we're shading in this direction, we are including the endpoint, and we're shading in this direction. Now our interval notation starts out here at -infinity and ends over here at +infinity. So open parentheses, -infinity up to -4 and including -4, union with, starting with -1 and including -1 as indicated by the brackets, and going through infinity. Cannot close off infinity. So that is our interval notation. So for part A, interval notation to infinity up to -4, bracket united with -1 up to +infinity. And then in graphical form, endpoint -4, and we shade to the left, -1, and we shade to the right. And there we have solved and provided solutions for this quadratic inequality.